Hello everybody. We are back and we are dealing with imaginary numbers, okay? This time we are dealing with more complex. Oops. Suppose I'll put my headset in, huh? Okay, you guys can probably hear me a lot better now. All right, so in this particular unit, all right, Unit 3, day, this is technically 8, okay? We are going to be working with more of these complex numbers, okay, in standard form, and just basically simplifying them and leaving them in standard form, okay? So if you notice in all these problems, okay, we got nothing but negative numbers underneath our radicals, right? So our job is to simplify these expressions based off of our knowledge of imaginary numbers and simplifying radicals, okay? So the first one looks pretty sweet, right? And this one here, okay, first thing you want to do is bring that I right out. Okay, anytime you see a negative in there, just bring that I right out. Okay, that's your first step, right? Remember, I is just equal to negative 1 underneath the radical, and so what I'm doing is, in this case, I'm separating the 81 and the negative 1, right? Using my rules of simplifying radicals. Okay, this is called the product property. And then we know that this is equal to I, so we're left with I square root 81. But, okay, what's significant about the square root of 81? Well, that's a nice number, right? That's actually 9. So we end up getting 9I plus, ooh, and 16 is another nice number. We end up getting 4I. So my answer is just 13I. Okay, and again, these are expressions, right? They're not equal to anything. We are just simply utilizing our tools of imaginary numbers and radicals in order to simplify these expressions, okay? So let's take a look at number 2. Okay, number 2, we don't have nice perfect squares, okay? Fortunately, number 1 was just a gimme, okay? So number 2, all right, first thing I want to do is, again, bring out that I value. So you're left with stuff underneath the radical. Okay? Now, our job is to simplify these guys, right? So 2 times 25, right? Again, I'm using the hockey stick method. 5 times 5. So here, we're getting a pair of 5s. Let me shrink this down here because I'm writing a little big. Right, so we're left with 3, times 5i, and then whatever's left underneath the radical, which in this case is a 2. Okay, minus. So here, hockey stick method, 125 divided by 5. You get 25 again, 5 and 5. So underneath the radical, okay, the 5 is going to stay. And then I'm going to multiply 6. 6 by 5, and then don't forget your I there, okay? So finally, we get 15I square root 2 minus 30I square root 2, okay? And the rules as far as adding terms that have radicals in them, okay, kind of like when we're adding stuff like 3x plus 3x squared, okay? In this case, we can't add those two, right? Why? They don't have the same base, okay? But if I had 3x plus 3x, well, I could certainly add those, okay? So the process is still the same. In order to combine these two things, we need not only that I value, but that same thing underneath the radical, which we do have, okay? And so we end up getting negative 15I square root 2. Oh, I messed that one up completely. No, we don't have a 2 under there. Hello, it's a 5. So we can't do anything. Okay, so actually, we're done. My bad. Leave it just like that. Hello. Okay, so, apologies. For some reason I thought there was a 2 under there, right? But, that being said, okay, that goes into the lesson, right? So in order to add these two things, okay, we need to have the same thing. We need to have an I and the same number underneath the radical, which we do not have. And so unfortunately, that's our answer, right? We can't do anything else with it. So that's it, okay? Let's take a look at number 3. Number 3. All right. Again, I'm going to bring out that I plus square root of 32 plus 3I square root of 8. Okay? So, I guess 8 can be broken down, right? Let's start with 72 here. So here's our prime numbers, 3, 5, 7, 11. Okay, so I'm going to start with a 2, so 2 and 36, 2 and 18, 2 and 9, 3 and 3. And so we're left with one pair, two pair. So I'm going to bring out a, and this is why the hockey stick method takes up a little bit of space. Okay, so I'm going to bring out a 3 and a 2, and the I, and what's left is just that 2. Okay, 32, I'm going to go 2 and 16, 2 and 8, 2 and 4, 2 and 2, hockey stick method, 1, 2, and so I'm going to get a 4, right, 2 times 2 is 4, and whatever's left underneath the radical, which is just a 2. Okay, so far, so good. All right, and finally, at the end here, we got this 8, so it's going to be 2 and 4, 2 and 2, hockey stick, bring out the 2, so 3 times 2, I, square root 2. Okay, and now I'm just going to combine like terms here. All right, so 3 times 2 is 6i. Over here we got a 6i. 6i plus 6i is 12i. Square root 2. Remember, we need both of those in order to add those. I need that I value, and I need that same thing underneath the radical. So unfortunately, even though we got the same thing underneath the radical, we don't have an I value with that 4 square root 2. So therefore, our answer is just left as is. Let's take a look at number 4. Okay, again, bring out that I value, negative I, square root 20, and then I, square root 180. Okay, so neither one of them are perfect squares, so let's do 20. We're going to go 2 and 10, 2 and 5, hockey stick, bring out the 2, so I'm left with a 5, 2 square root 5. So my answer for the top piece is going to be a negative 2i square root 5. Then on the bottom, square root 180, so we're going to go 2 and 90, 2, 45, 5 and 9, 3 and 3. So our hockey stick, here's our hockey stick. I'm going to bring out a 2 and a 3, and the 5 gets left behind. So 2 times 3 is 6i square root 5. Okay, but hey, look at that. All right, this is where we can still be allowed to do some cancellation. So what can get canceled? Well, get rid of that 5, right? Square root 5 divided by square root 5 is 1, right? You can divide these I values, and finally, I can divide the top and the bottom by a 2, and so my answer is a negative 1/3. Let's take a look at number 5. Okay, number 5, 1/2. We bring out that I value, so I'm left with square root 200 minus I square root 32. Didn't we already do square root 32? Right, square root 32 is just 4 square root 2. So we already got this one, so this one's going to be 4i square root 2. Okay, but we haven't done 200 yet, so let's do 200 up here. So 200, 2 and 100, 2 and 50, 5 and, whoop, how about 2 and 25? And then 5 and 5. Okay, so hockey stick. Let me move this up a little bit. Okay, so you're going to take another 2 and a 5, so that's equal to 10. So 1/2 times 10i. And what do I have left? Square root 2. All right, so let's figure this out here. Well, half of 10 is just going to be 5, right? So 10 times 1/2 is just going to be 5i square root 2 minus 4i square root 2. And again, I can combine these because we have these same like terms here, right? I and square root 2. So 5i square root 2, and think of it like this, 5x minus 4x, right? Well, that just equals 1x, right? So here, 5i squared minus 4i squared just equals square root, sorry. 5i square root 2 minus 4i square root 2 is just equal to I square root 2. Let's take a look at number 6. Okay, number 6. Bring out that I value. Whoops. And so we're left with square root of 9 times I square root 5, or 25, sorry. Yo, messing things up here. Getting ahead of the game. All right, so bring out that I first. I apologize. All right, so next thing, all right, we can simplify those, right? Square root of 81 is just 9 times, and then the square root of 25 is just 5. So I'm going to multiply, oops, don't forget that I. All right, so negative 4 times 9 times 5. So I get a negative 180 I squared, but remember I squared is just equal to a negative 1, so I end up with a positive 180. Let's keep going. All right, for number 7, bring out that I value. Square root 6 times 2/3, why would they do that? I square root 6, okay? So, remember, when we're multiplying square roots, right? If I multiplied 6 times square root 6, that actually is equal to 6. And if you think about it, right? If we're following the rules of our radicals, we put the 6 and the 6 underneath the radical. 6 times 6 is 36. And what's the square root of 36? 6. Okay? So, just keep that in mind. So, our last two pieces are just going to be 6. Now let's multiply the other numbers here, all right? So we're going to get an I squared, right? I times I is going to be I squared. And the last two numbers we have to multiply is the 2/3 and the 6. So 2/3 times 6 gives us 4. Okay, so I multiplied these two guys, I multiplied the two 6's, and then I multiplied the two i's. All right, so I end up getting 24i squared, which again, I is equal to a negative 1, so we end up getting a negative 24. And finally, last but not least, I'm going to multiply this guy out. All right, first, I want to, before I do that, let's bring that I out, right? And so, luckily, in this case, when I bring that I out, we're left with the square root of 16. Well, the square root of 16 is just 4. So, in parentheses there, I'm getting 5 plus 4i. And then on the other side, all right, I'm bringing out that I value. But then what's the square root of 4? Is 2. So our back piece is that guy right there. Okay? And now I can multiply, right? I didn't want to multiply before I could, but it's much easier to do it this way, right? So we get negative 10 plus 10i minus 8i plus 8i squared. Okay, so let's do some simplification. So negative 10 plus 2i plus 8i squared. Now remember, I squared is just equal to a negative 1. And so we end up getting, shrink this down here, we end up getting negative 10 plus 2i minus 8. And so our final answer, negative 18 plus 2i. Okay. Let's finish these ones up at the bottom here. This last two, and we'll call it a day. Okay? So, we're trying to find what value, right, make this statement true. Okay? So in order to do that, right, we need to set the real parts equal to each other. So we'll go A is equal to C, and B, or BI, is equal to D. Okay? So, what do I mean by that? Well, let's take a look at the first piece. Okay, so here's our real part of our problem, right? So 6x is equal to 30, which means x is equal to 5. Okay. Now, solve for y. So we get 10yi is equal to 50i. All right, so I divide by 10i, divide by 10i, and what do I get? Y is equal, again, to 5. Okay, so what values for x and y make this statement true? Those two values right there. Okay, but you can kind of see, right? How do I get from 6 to 30? Well, x must be 5, right? And how do I get from 10 to 50? Well, x must be, or y must be 5 again. Okay, so that's what we're doing for these particular problems. All right, now, unfortunately, B, okay, we got a little bit of work to do before we get started here. So I'm going to multiply this out. So 6 times 14 is equal to 84 minus 24x minus 80 yi plus 60i, ooh, I'm going to run out of room here, okay, is equal to, okay, so then 2x minus, and I got to distribute this 4i here, so we're going to get a negative 8i minus 8i, or 8yi, okay? Oh, all right. So, let's do some simplification here, put some stuff back together. All right, so I'm going to get my y's together, and I'm going to get my x's together. All right, that's what we're going to have to do next, right? Because right now I got 8iy on one side, I got a negative 80yi on the other. Okay, so I'm actually going to add 80yi to both sides. All right, and by doing so, it cancels over here, so I'm left with 84 minus 24x plus 60i is equal to 2x minus 8i. That's going to be plus 72iy. Okay. All right, next move, I'm going to get my i's all together, so I'm going to add 8i. So I get 84 minus 24x plus 68i is equal to 2x plus 72iy. All right, and finally I'm going to bring over this 24x so that now I'm left with 84 plus 68i is equal to 26x plus 72iy. And now we are able to solve. Okay, so I'm going to set my real numbers equal to each other. So 26x is equal to 84 divided by 26. I think that's an even number. Okay, I guess not. So you end up getting 84 over 26, which we can math frac that guy, which is equal to 42 over 13. And then finally, my y, I'm going to have to go 68i is equal to 72iy divided by 72i. And I get y is equal to, so 68 divided by 72, math frac, 17 over 18. Okay, so again, process for these, all right, is simply setting it. So you want to kind of set it up like we have in A here, all right, where we have all of our variables on one side. As you can see, we got x and y on one side here. Okay, and again, that's what I did here, right? I had x and y on the right, and then just my complex number on the left. Okay, so that's what you want to do first, and then you set the a terms. The a's are equal to the c's, right? So the ones that don't have the i's, you set equal to each other, and the ones that do have the i's, you set equal to each other in order to find those variables. Okay, so any questions on this, feel free to ask. Good luck, you guys, and your homework is all of the odd problems. Okay, good luck.